Hello everyone, welcome to this video where we will learn about the TCP/IP model. This is one of the most important concepts in networking and the internet. The TCP/IP model is basically the rule book that computer follows when they talk to each other on a network or the internet. Don't worry if this sounds complicated. By the end of this video, you will understand exactly how it works. So let's get started. Now let's understand what the TCP/IP actually means. TCP stands for Transmission Control Protocol and the IP stands for Internet Protocol. Together they form the backbone of all modern networking and the entire internet. Think of a TCP/IP model as a set of rules, like a guidebook that tells computer how to send and receive information with each other, no matter what they are in the world. Here's an important point. Not all computers are same. Some are Windows, some are Mac, and some are Linux based. And not all the networks are same either. Some are fast, some are slow. So we needed a common language, a standard framework that all these different computers and networks could understand and follow. That's exactly what the TCP/IP model does. It standardizes communication. It makes sure that when your phone sends a message to someone's computer or when you watch a video online, the data travels correctly from the sender to the receiver. Without the TCP/IP model, the internet as we know it wouldn't exist. Every single time you use the internet, whether you are sending an email, watching on YouTube, or browsing a website, you are using the TCP/IP model, even if you don't realize it. Now, you know why this model is so important. Okay, so here's the key thing about the TCP/IP model. It's organized into layers. Think of it like sandwich. Each layer has a specific job to do. This TCP/IP model has four main layers, starting from the top and going down. First, the application layer. This is what the users see and interact with. Second, transport layer. This manages how data is sent and received. Third, internet layer. This handles the routing and addressing of data. And finally, at the bottom, the network access layer, also called the link layer. This deals with the actual physical transmission of data. Each layer works with the layer above it and the layer below it. Together, they make sure your data gets from point A to point B safely and correctly. Think of it this way. If you want to send a letter, the application layer is your writing the letter. The transport layer is the postal service organizing it. The internet layer is planning the route and the network access layer is actually transporting it by truck or plane. Doesn't make that sense? Let's dive deeper into each layer. Before we explain each layer in detail, I want to show you this diagram which displays all the layers and the key protocols used in each one. You will see the four layers on the left, and on the right you can see the specific protocols, the technical rules that each layer uses. Don't worry if you don't know all these protocols names right now. We will explain the most important ones as we go through each layer. This diagram is just to give you a visual overview of everything we are about to cover. Let's start with the top layer, the application layer. This is the easiest one to understand because it's the one you actually see and use every day. The application layer is where all the applicants that you use live, things like email apps, web browsers, file sharing apps, and messaging apps. This layer directly interacts with you, that is the user. So what does this layer do? It provides network services. What are the network services? These are the things like HTTP, FTP, DNS, Telnet, SMTP, and POP3. HTTP. This is what makes web pages work when you type a website address in your browser. FTP. This is used for transferring files from one computer to another. DNS. This converts website name into addresses that computers can understand. For example, when you type google.com, DNS converts it into a number that your computer can use. Telnet. This allows you to log in to other computer remotely. SMTP and POP3. These are used for sending and receiving emails. Now, here's an important job of this layer. It takes your data, like the email message or the video you want to watch, and formats it in a way that both of your computer and the receiving computer can understand. In simple words, this layer is like a translator. It makes sure that when you send something, it's in a language that the one computer can others understand. Now, let's move to the second layer, the transport layer. This layer has a very important job. It makes sure your data arrives at the right place, in the right order, and without any damage. What does this layer actually do? First, it handles end-to-end communication, meaning it ensures that get data gets from the sender all the way to the receiver correctly. Second, it does error control. If something goes wrong or data gets corrupted during the transmission, this layer detects it and fixes it. Third, it does flow control. This means it controls the speed at which data is sent. If the receiver can't handle data coming too fast, the transport layer slows down. Now, there are two main protocols used in this layer, TCP and UDP. TCP, Transmission Control Protocol. This is reliable. Before sending data, TCP checks that the connection is good. It then sends the data in the correct order and makes sure everything arrives completely. It's like sending a registered letter, you get a confirmation that it arrived. However, because it's so careful and reliable, it's a bit slower. You use TCP for things like checking emails or browsing websites where accuracy is more important than speed. UDP, User Datagram Protocol. This is faster but less reliable. UDP doesn't check if the connection is good before sending. It just sends the data quickly without worrying if all of it arrives. It's like throwing a letter in the mail without tracking. It might reach it, it might get lost. You use UDP for things like online gaming, video streaming, where the speed is more important than receiving every single piece of data perfectly. So, the transport layer is like a delivery service. It gets your package to you, but how carefully it does, it depends on which protocol is used. Next, let's understand the internet layer. This is the layer that knows about the big picture, the entire network, and all the routes through it. The main job of the internet layer is routing and addressing. What does this mean? Addressing means giving each device a unique address so we can identify it. Think of it like a postal address. Every house has a unique address so the mailman knows to deliver. Routing means finding the best path for data to travel from sender to the receiver across the network. With millions of devices on the internet, data might have to pass through dozens of different routers before it reaches to the destination. The internet layer figures out the best route. Now, what protocols does this layer use? IPv4 and IPv6. These are addressing protocols. They assign unique addresses to each device. For example, IPv4 address looks like 192.168.1.1. These addresses help identify which device is sending data and which device should receive it. ICMP and ICMPv6. These are used for error reporting and diagnostic. If something goes wrong, these protocols send error messages back to help troubleshoot the problem. IGMP. This is used for multicast communication, which means sending data to multiple receivers at once, like in a video conference. Routing protocols like OSPF and EIGRP. These are used by routers to talk to each other and decide the best path for data to track. In simple terms, the internet layer is like the GPS of the network. It makes sure data takes the most efficient path to its destination. Finally, let's understand the bottom layer, the link layer, also called the network access layer or the data link layer. This is where the physical stuff happens. While the layer above it deals with the software and logical rules, this layer deals with the actual physical transmission of data. It's where the rubber meets the road. What does this layer do? First, it handles encoding and transmission of data. The data from the upper layers is converted into bits, zeros and ones, and then the physically transmitted over the medium, whether that's a copper wire, fiber optic cable, or wireless radio waves. Second, it does framing. It takes the data and puts it into frames or packages with headers and trailers. So the receiving device knows where one piece of data starts and another ends. Third, it handles error detection. It checks if the data was received correctly and hasn't been corrupted during physical transmission. Fourth, it uses MAC addressing. MAC stands for Media Access Control. Every device has a unique MAC address that identifies it on the local network, while IP addresses work across the entire internet. MAC addresses work only on your local network. Now, what protocols does this layer use? Ethernet. This is the most common protocol, or local area networks, or LANs. It's what connects computers in your homes or offices. Frame relay. This is used for wide area networks, or WANs, network that span larger geographic areas. PPP, point to point protocol. This is used for direct connections between two devices. Wi Fi. This is the wireless version of Ethernet. In simple terms, if the internet layer is the GPS, then the link layer is the actual road and the vehicle that carries the data. It's the physical layer where data actually moves. Now, as we know, every technology and anything has some merits and demerits of it. So let's look at the merits and demerits of the TCP/IP model. Merits. First, it operates independently. It works the same way on any device or operating system, like the Windows, Mac, Linux, smartphones, it doesn't matter. Second, it is scalable. The TCP/IP model can grow and expand to support billions of devices without any problem. Third, it uses a client-server architecture. This means clients request information and server provides it, making the system recognized and efficient. Simple. Fourth, it supports a number of routing protocols. Different routing methods like OSPF and EIGRP help find the best path for data. Fifth, it can be used to establish a connection between two computers. Any two computers anywhere in the world can communicate with each other using TCP/IP. Now, the demerits of TCP/IP model are: first, the transport layer does not guarantee delivery of packets. Some packets of data might get lost during the transmission. It doesn't promise everything will arrive. Second, the model cannot be used in any other application. TCP/IP is designed specifically for networking and internet communication. It can't be used for other purposes. Third, replacing a protocol is not easy. Once a protocol becomes standard, it's very difficult to replace it with a new one because everything is built around it. Fourth, it has not clearly separated its services, interfaces, and protocols. The boundaries between layers aren't always clear, which can make it confusing to work with. So the TCP/IP model is powerful and universal, but it has some limitations in terms of flexibility and reliability. So, wrapping up the things, today we learned about the TCP/IP model, its workflow, and how different layers of it combinedly helps in the communication between two devices globally. We have also seen the merits and demerits of the model. I hope you understand about this topic completely. Thank you.